Okay, so today, right, we are doing something called fractions. All right, we'll be doing something called improper fractions and mixed number. All right, some of your school might have covered that already. Okay, and after that, we will be going into something called Kahoot. So today we have time for Kahoot. All right, so later you have to borrow your devices from your parents, and we will log into Kahoot to play some games. And after that, we will be finishing off with some of the fractions word problems. All right, so today lesson is actually quite okay. Don't worry about it. All right, today is quite relaxed. Can? All right, so let's go into our first portion, which is the notes area first. All right, the notes area. All right, so usually I will start off with some quick notes, some of the important things. So these important things, if you can, do write out what I write. All right, do write out what I write. So in primary three, all right, in primary three, we actually started off with this topic called what? Fractions already. Fractions. All right. And in primary four, of course, you have seen the topic of fractions. All right. But slowly, we introduce you something called what? We introduce you something called proper fractions. Huh? There's proper fractions, God. So proper fractions, right, actually means what? It means that the numerator, right, the number, right, the numerator is always smaller than the denominator. All right, so this on top is called the numerator. The number is smaller than the denominator. All right, so for example, you have things like what? For example, you have things like 2/3, 2/3. Can you see now? Right, the numerator, the number is smaller than the denominator. All right, so that is like the normal proper fractions that we have been dealing with every time. All right, other examples are, for example, 4/5. Can? Can. All right, whereby the numerator, the number is smaller than the denominator. All right, so these are just examples. Then slowly in primary four, right, you upgraded into something called what? Not proper, not proper. The opposite is improper lah. All right, it's like possible and impossible lah. All right, so proper and improper, improper fractions. So there is something improper about it. There's something that is weird about it. All right, what is weird about it is the opposite. Right, is the opposite. Whereby now the denominator, all right, is actually smaller than the numerator. Oh, all right, there is something improper about it. Okay, that's the reason why it's called improper fraction. Right, the denominator is smaller than the numerator. For example, don't worry. For example, again, all right, we have things like 3/2. Ooh. Can you see? Can you see? All right. So the denominator, which is the bottom number, is smaller than the numerator. All right. So that is called an improper fraction. Right. Other examples is what? Other examples is the what? All right. For example, we have, let's say, 7/3. This one is also improper fraction. Can? So last time I like to disturb. I like to draw picture. All right. So I always say that for proper fractions, right, it's the correct. It's like the head, right? The head is smaller than body of a person. All right. So this is like my drawing of a person. All right. The head is smaller than the body. Okay. So that's a proper person, you see. But improper person means what? Ayo, the head is bigger than the body of the person. So have you seen people with big head? Yes lah, of course. All right. So there are some people who wear what? who wear the mannequins and walk around. There's one very popular one, the bear one. Have you seen the bear one? All right, so it's a, I don't know, it's a her or a him. All right, so this person will actually put on the bear costume, right, with a very big head, and the body is very small one. So you go around bouncing, and disturbing other people and all this. Very funny one. All right. So usually what we call improper is like the one with a bigger head lah. Whereby the numerator is small. The numerator has a bigger number than the denominator. And slowly from improper fraction, right? Slowly from improper fraction, all right, it brings you to something called the last portion. It's called a mixed number. So all these are under fractions. All these are under fractions. All right. So a mixed number, right, from the word itself, mixed number means it's a what? A mixture. A mixture. Right? So you will have some numbers, you will have some fraction. All right, you have some numbers, you have some fraction. All right, so for example, 3 over 2, right, actually can be written as 1 whole, 1 over 2. All right, 3 over 2 can be written as 1 whole, 1 over 2. So that consists of some numbers and some fraction. Hey, but Cher, how do you get 1.5? Okay, so the meaning of over, right, just to let you know, the meaning of this over, what does it mean? All right, it actually means 3 over 2 is actually the same as 3 divided by 2. All right, 3 divided by 2. All right, they have the same thing. All right, so usually when we have 3 divided by 2, what happened? All right, we can do a little working like that. So 3 divided by 2. All right, remember, this is in front. The 3 is in front. In front will be inside. All right, it will be inside the working now here. All right, so 3 divided by 2 will be equal to 1. All right, 2 times 1 is 2. And there will be a remainder of what? There will be a remainder of 1. All right, so how do you present this as a mixed number? All right, you can present it as the red color 1. Is like the 1 whole here. All right, the remainder 1 is like the 1 on top. All right, and the fraction is 1 over what? 1 over 2. The denominator is still a 2. Can you see? All right, so if you can follow the color coding a little bit, it will be a little bit useful. So the main number or the quotient, this one we call it the quotient. Right, the quotient will appear where? The quotient will appear here. Okay, the remainder R stands for what? Remainder. The remainder will appear here. And this portion, the denominator here, will appear here still. So if you follow the pattern, right, it's actually quite easy to go through. Okay, so how about 7 over 3? All right, so how about 7 over 3? A quick one, come. Whoop, cut the head. All right, 7 divided by 3 is like, for example, 7 divided by 3, right? So 3 times 2, 2 is the quotient, that's why the 2 is the number, will give you a remainder 1 here. All right, since there's a remainder of 1, 1 over, the denominator is a 3. So you just put a 3 below here. Correct. All right, Leming, don't worry. You're still early. All right, I'm just starting only, don't worry. Can you go through division over 10? What do you mean? All right, so if you want to divide by numbers over 10, for example, I don't know, is that what you mean, Chandra? All right, so for example, you are telling me to take, for example, 725 divide by, let's say, 17, is it? Can? Chandra, is that you? All right, so for example, right, a student's asking, how do you take, how can you go through division over 10? Okay, yes. So what is 725 divided by 17, for example? What do you do? Without calculator, what do you do? All right, since one of the students is asking such question, all right, I don't mind teaching you guys. All right, it's actually the same process. This number 725 is in front. In front is actually inside. Inside where? Inside this portion here. Right here. Can? Alright, so your 725 is here. And your 17 is here. Again, this is a random number, children. It's a random number. Alright. So down here, you need some what? You need some 17 timetable. The help of 17 timetable. So at the corner, right, I will actually list out the multiple of 17. Because the number is getting huge, right? So 17 after that will be 34, right? So 17 plus 17 is 34. Is that true? 34 plus 17, you go and try. 3 plus 1 is 4. 7 plus 4 is 1. So transfer is 51. After that, 51 plus 17 is 68. Can you see that? So what am I doing? I'm actually listing out some of the 17 timetable. These are the multiple of 17. Can you see that? All right, I'm just listing out some of the multiples of 17. Okay, let's play. So down here, how do you do your division? 17 times what is 7? Got or not? Don't have. 17 times what is 72? 72 is near which number? 72 is near 68. Can you see? All right, so this is 17 times 1, 17 times 2, 17 times 3, and 17 times 4. So I put a 4 down here. It's the same thing. All right, it's just that the numbers is larger. It's scarier. I totally understand. All right, that's the reason why I write out the multiple of 17 on my left. At least I got some backup to check back. All right, 68 to 72. Count upward 69, 70, 71, 72. It's a 4 down here. Bring down the 5. 17 times what is 45? Closest is 34. Can you see? All right, cannot be 51. 51 will be overshot. So 17 times 2 will be 34. And down here, you will have a remainder of 1, 1. You see? Remainder. All right, so your answer will be equal to 42, remainder 11. Is that okay? All right, that's how you divide by a big number. All right. Okay, so down here is talking about fractions. Fractions from improper to mixed number must know. And mathematics, right, is also about two directions. You must make it from improper to mixed and also from mixed back to improper. It's all about these two directions. Okay, so just now improper to mixed, okay, shouldn't be a problem. Okay, so now if you are given a mixed number, how do you change it to a improper? Right, so for example, you are given 4 and 3 over 5. All right, my advice to you, start from the denominator. All right, your teacher also taught you this, I believe. Start from the denominator. And you go in a clockwise direction. 5 times 4 first, then plus 3. 5 times 4 is 20. 20 plus 3 is 23. And the denominator is still a 5. The denominator will always be the same. So that's called a improper fraction. Right? Another example, maybe. For example, we have 7 and 2 over 7. All right. Once again, start from the denominator 7. Go in the clockwise direction. 7 times 7 plus 2. 7 times 7, 49, 49, 49, 50, 51. So it's 51 over 7. Can you see that? That's the way to do it. And children, whatever it is for fractions, all right, put a star down here. Fraction. Put down a star down there. Always give to the simplest form, to the lowest term, or the simplest form. But sure, the question never say no argument. No argument. Always give it to the simplest term or the lowest form. No argument. Question say, question don't say, you do it. Always give it to the lowest term. All right. That means you have to use equivalent fraction. You cannot present your answer as this, for example. Right? You cannot present our answer as 4 and 2 over 4. Cannot. This is incorrect. All right. You have to present it as what? 4.5. This is correct. All right. So how do you get half? You have to use equivalent fraction. Divide by 2 on the numerator. Divide by 2 on the denominator. So please, children, right? Very, very important.